Section 4.4 Non-homogeneous equations, the method of undetermined coefficients. In sections 4.2 and 4.3, we learned how to find the solutions of the homogeneous equations, and we are still working with the same type, the linear second order differential equation with constant coefficients. So here A, B, C here are constants, and but in the 4.2 and 4.3 the homogeneous case we had a 0 on the right hand side, but now we are looking at functions which are not 0. So in that case the solution will be called a particular solution, and we denote it by y sub p. Now it doesn't have to be y sub p of t, it could be y sub p of x or some other variables, or whatever the variable independent variable is, you can put it there, or even if you just write yp, that will be fine. So method is simple, but sometimes it can be a little bit too long, but involves mostly algebra. So it goes like this, that we look at the function f of t on the right side and we make a guess, and then we expect that basically how do we make the guess? We expect that the solution will be similar to the function on the right hand side, and if we encounter some problems, we will have to redo it, guess again. So if we can determine values for the coefficients, then we guessed correctly, and if we can't, then we will have to guess again. So let's look at how we go for it, and then once you get an idea, then you don't have to do the guess. You can use the techniques learned and actually start with the correct guess. So here, first example, we are given y double prime plus 3y prime plus 2y is equal to 3t. So I have solved most of the problems here because just to save time. Okay, so on the f of t is 3t, so we guess that, okay, maybe coefficient might be different, but our function maybe looks like 8 times t. So what we do, we have to plug this function now into the differential equation, so we need the first and the second derivative. So y prime will be a for at, and y double prime will be 0. So we plug in the dE, so we end up getting 0 plus 3a plus 2at is equal to 3t. Now we compare the coefficients. How do we compare the coefficients? Well, this is a polynomial on both sides, so we compare the coefficients depending on the degree or the power on the independent variable. So if you notice, this term has a t in here and this term does not have a t. 0 will be gone, right? We don't care about that. So our equation looks like 3a plus 2at equal to 3t. So on this side, right hand side, we only have the term with t here. So what about the constant term? So we can say plus 0. So 3a will give us equal to 0. So 3a is equal to 0, and 2a is equal to 3, because you will compare the coefficients of these two. So you are getting two values of a in the same problem. One is 3 over 2 and the other is 0. So this cannot happen. This is a contradiction, so it means our guess is not correct. So we have to guess again. So this time we try at plus b. So what is that? That is this is the linear polynomial, right? So you see here we had just t in the beginning of in the function f of t was just 3t. So what is this? This is a linear polynomial. So we have to, when we guess, remember, whatever the degree is, we have to take the whole polynomial for that, not just that term, if we have a polynomial for f of t. Okay, so let us try y is equal to at plus b. Then y prime, the derivatives will be y prime is equal to a, y double prime is equal to 0. So still same derivatives, but now when we plug in, so 0 for y double prime plus 3 times a for y prime plus 2 times Now for y, instead of just getting at, now I have at plus b, and equal to 3t on the right hand side of the equation. So we now simplify left hand side. I'm putting the same terms, in the like together. So we have only one term with the t, and there are two terms with the constants. So 3a plus 2b. So 3a plus 2b plus 2at is equal to 3t. That's what the equation becomes. Now we compare coefficients again. Now 3a plus 2b will be equal to 0, and from here 2a will be equal to 3. So now from the first one, from this equation 2a is equal to 3, I can immediately find a, which is coming out to be 3 over 2, and then I plug into the other equation and I will end up getting the b. So b is coming out to be negative 9 over 4. So our particular solution is 3 over 2t plus minus 9 over 4. So this is how we find the particular solution. Another example, y double prime plus 3y prime plus 2y equal to 10 into e to the 3t. So again, guessing, because on this side we have just e to the 3t, so it looks like our function should be have e to the 3t, but what is going to come in front we don't know. So we say let y is equal to a times e to the 3t. Then y prime is equal to 3a e to the 3t, and y double prime is equal to 9a e to the 3t. So plugging in the equation, in the differential equation, so 9a e to the 3t, this is the y double prime, plus the y prime, and plus the 2y term, and then equal to 10 e to the 3t. Now we combine the terms on the left because we can. All of the terms are just multiples of e to the 3t. So I end up getting 20a e to the 3t is equal to, on the right hand side we have 10 e to the 3t. What does that mean? When we compare the coefficients, we are, whose coefficients we are comparing? Coefficients of e to the 3t. So we get 20a is equal to 10, which means a is equal to 1/2. So our yp is equal to 1/2 e to the 3t. So this time our guess worked. Okay, I think I'll stop here and